Test delay, everybody. So this is part 3 of my video lesson on the very first chapter. There is some basic concepts of chemistry. Now in part 2 you learned about Dalton's atomic theory. Then you learned about atomic mass unit. You also learn about how to find the relative atomic mass of an element. Then you learn about how to find the average atomic mass of an element. Apart from these, you also learn about the molecular mass, then formula mass, and then we did some numerical problems or calculations based on these. And then we also learned about, mole concept and molar mass. And there we worked out some numerical problems. And in fact, as I told in the last video class, I will continue with the numerical problems in the next part, that is part 3. So today, we're going to continue with the numerical problems or problems on mole concept and molar mass. And after that, we're going to take up percentage composition of a compound. So students, at the end of this part 3, you'll be able to understand, explain, and then work out problems on percentage composition of a compound. And then after that, students will also learn or will be able to define what is an empirical formula, what is a molecular formula, and also work out some numericals based on how to find the empirical formula and the molecular formula of a compound when the mass percent of the various elements that are present in a compound are given. So we'll talk about this later. Now, continuation of last part 2, that is continuation of numerical problems on mole concept and molar mass. We're going to now work out some problems, right? But before that, you know the meaning of mole. And then you know the meaning of molar mass. Let me just tell you once again, as far as mole is concerned, mole is the unit for the amount of substance, and the symbol for this unit, mole, is MOL. That's it. And now if you're asked to define 1 mole is defined as the amount of any substance that contains as many particles or entities as there are atoms in exactly 12 grams of carbon-12 isotope. So I don't have to explain these things once again because I've explained these in detail in the previous video section, that is part 2. And then the other thing is molar mass. Now the mass of 1 mole of any substance expressed in grams, it is called the molar mass, right? Okay, so these two have been explained in part 2, and based on this now we're going to work out some problems, numerical problems. So now, as far as this 1 mole is concerned, now you know that I've written it there also. See, in 1 mole of any substance, you have seen that there are 6.022 into 10 raised to the power 23 particles. Now these particles may be atoms or molecules or electrons or ions or whatever. So that is a number, and it's called the Avogadro constant, and it's denoted by the symbol capital N with subscript A. So that's the Avogadro constants. And then the next thing is with regard to molar mass. As I said just now, the mass of 1 mole of any substance will be expressed in grams. That is called the molar mass. Just an example, you know that the atomic mass of hydrogen, the atomic mass of hydrogen is 1 AMU, or 1 unified mass. Now when you express this in terms of grams, it is called the molar mass. This becomes the molar mass. It is the molar mass of hydrogen atoms. And this molar mass of 1 gram of hydrogen atoms is called 1 mole. This is 1 mole. And then the number of atoms of hydrogen, in 1 mole of hydrogen atoms is again 6.022 into 10 raised to the power 23. That's it. Got it. Now, see, you can now straight away write, for instance, the molar mass of, if you take, say, dihydrogen. Now, when I say molar mass, the mass has to be expressed in terms of grams. Now, the molecular mass of hydrogen, molecular mass is, there are 2 atoms of hydrogen, so it becomes 2 AMU. And when you express this in terms of grams, it becomes the molar mass. So this is the molar mass. Molar mass of what? Molar mass of the dihydrogen, right? Okay. And this 2 grams of dihydrogen is nothing but 1 mole. This is 1 mole of dihydrogen gas, dihydrogen. And now, in this 1 mole, that is 2 grams of dihydrogen, you're going to have, how many? You will have 6.022 into 10 raised to the power, this is into 10 raised to the power 23 what? Molecules of dihydrogen. So you will have a total of 6.022 into 10 raised to the power 23 molecules of dihydrogen, that is H2, right? So you will have this one 6.02 to the 10 raised to the power 23 molecules. You'll have H2 this many times. Now, if I go one step further, we can also find the number of atoms of hydrogen in 1 mole of dihydrogen. That is, in 1 mole, you have this many number of molecules of dihydrogen. Now, in each molecule of hydrogen, dihydrogen, you have 2 atoms of hydrogen. So now, the total number of atoms, that is, number of atoms of hydrogen in 1 mole of dihydrogen. This is dihydrogen, right? H2 is, in 1 molecule you have 2 hydrogen atoms, right? Suppose you have 2 molecules, suppose you have 2 molecules of dihydrogen, you will have 2 times that number, right? In 1 molecule you have 2 hydrogen atoms. In 2 you will have 2 into 2, 4. So you will have to now multiply this number, that is, in 1 mole of dihydrogen you have this many molecules of dihydrogen. Now, talking about the number of atoms, you will have twice this number, because in each molecule you have 2 hydrogen atoms. So there are this many, 2 into 10 raised to the power 23. This is atoms now, right? So number of atoms of hydrogen in 1 mole of dihydrogen is 2 times 6.02 10 to 23, right? That's because in each molecule of dihydrogen you have 2 hydrogen atoms. Since you have this many number of molecules of dihydrogen, the number of atoms will be twice the number. So this is equal to, okay, if you multiply 2 2 4 there, 2 2 4, 0, 2 6 12 into 10 raised to the power 23 atoms. If I'm not wrong, I hope this is right. And then you have a decimal point coming 1 to 3, 3 digits on the back side, 1 to 3 here. And when you write this in the scientific notation form, it becomes 1.2044 into 10 raised to the power. Since you've shifted the decimal point to the left by 1, you'll have increased this exponent here by 1. It becomes 24 atoms of hydrogen, right? That's it. So this is just a basic explanation of these things. So let's see. Now we're going to work out some problems related to the same. In fact, I think we worked out 2 problems in the last part, that is in part 2. So now the next problem that I want to work out is, let's see, I have it ready here for you. So this one is a very simple one. Let's take this as question number. Now I'm going to take this one. Okay. So you're going to find very simple ones. Find the number of moles of water in the following, right? You're going to find the number of moles. You know how to find the number of moles, right? So the very first one, you are given 360 grams. The second one is just 9 grams. In the third one, you are given, I think it's 4.5 grams. And the fourth one, it is 36 kilograms. Okay, that's it. Now, let's work it out. Solution number 1, the first one, you are given 360 grams. It is 360 grams of water. Now, in 360 grams of water, how many moles of water are there? This is what you're supposed to find. Now, as far as water is concerned, you know that it's molar mass. Now, we got to talk in terms of molar mass. When you know the molar mass, okay, that's 1 mole, right? So, hydrogen, there are 2 hydrogen atoms. So, it is each hydrogen atom, its atomic mass is 1. You multiply it by 2, and then you have 1 atom of oxygen. It is 16. It's just ones. So, this is 2 ones. It is 2 plus 16. It is nothing but 18, right? 18. Now, since we want the molar mass, that is the mass of 1 mole of water, you take it as 18 grams. So this is actually 1 mole. This is 1 mole. So 1 mole. So 18 grams of water is equal to 1 mole. 18 grams is the molar mass of H2O. Now, taking this as the standard expression, you can easily find. So let's see. We know that. I put it this way. We know that. Okay. 18 grams of H2O is equal to 1 mole of water. Right? Now, when you are given 360 grams of water, this is equal to how many moles? You can take it as X. Now, since this is a case of direct proportion in the sense as the number of grams of water increases, the number of moles of water will also increase. So this is a case of direct proportion. So you will now cross multiply. You have learned this in your lower classes. So when I cross multiply, I'll get 18 grams of water into X equal to multiply these two. So finally, I put X here equal to multiply these two. This is 360 grams of water into this is 1 mole of water, right? I put it like this. Then you're going to divide it by, when you cross multiply, you'll get this 18 coming down here. This is 18 grams. Okay, gram and gram get cancelled. So finally, this is 18 ones, 18 2 times 36, and then 18 0 0. So this is 20. So finally, it is equal to 20 into 1. It is 20 moles of water, right? So 20 moles of water. So you can write therefore, okay, 360 grams what? Okay, has 20 moles of water. That's it. And then now you can do the same thing for the second one, 9 grams. Now knowing that, see second one, okay, put it this way. So, you're given 9 grams of water. So you write, we know that 18 grams of H2O is equal to 1 mole, we call it 1 mole. If that's the case, then 9 grams of water is equal to how many moles? Let's put X here. Since it's a case of direct proportion, you cross multiply, your X is going to be 9 grams into, this is 1 mole of, it is water only, right? Water. The whole thing divided by, this 18 will come down here, 18 grams. Gram and gram get cancelled. That's 9 ones, 9 2 is 18. So it is equal to 1 by 2 is half. It's 0.5 moles of water. So now you can see that in 9 grams of water, you're going to have half a mole of water. That is half a mole. That's it. So now you can do the same thing for the rest. Like the third one, 4.5 grams, same thing. And this is 36 kg or 36 kilograms. So here you're given 36 kilograms of H2O. Now the important thing here is to convert kilograms into grams. And what you can do is to convert kilograms into grams, you have to multiply it by 1000, isn't it? Because 1 kilogram is equal to 1000 grams. So if you put this is equal to 36, you multiply by 1000, it becomes 36,000 grams. And then you apply the same rule here. That's how you can work it out. So finding number of moles of any compound or any element is very simple. That's it. So what you will do is you will divide the mass of the given substance by its molar mass, and then you can easily find the number of moles. That's it. Now the next question is question number 2. Find the number of molecules of water. Number of I'm going to make this simple one. That's it. Number of molecules. Find the number of molecules of water in the following. So the very first one. Okay, what I have written here is not in the following. It's just in 10 moles of water, right? 10 moles of water. Number of molecules of water in 10 moles of water. So now, again, here it's number of molecules. Number of molecules, now you have seen this Avogadro number. So we know that in 1 mole of any substance, you're going to have 6.02 to 10 to the power 23 particles, whether it's atoms or molecules or whatever. So here is water. Number of molecules of water is what you're going to find. So here we know that what we know is 1 mole of water. Write H2O. I'm going to write H2O here. 1 mole of H2O contains how many? 6.022 into 10 to the power 23. This is molecules, right? Molecules of water. Molecules of H2O. Now when you're given 10 moles of water, then you will see 10 moles of water contains, okay, how many molecules of water? Let's take it as X. Now since this is also a case of direct proportion, you will just cross multiply, and here you're going to get now X is equal to, you cross multiply, it is 10 moles of water into 6.022 into 10 raised power 23, it is molecules here, right? Molecules of water, that is. The whole thing divided by, this comes down here. So it is 1 mole, right? 1 mole of water. Mole and mole get cancelled. So finally, you are left with 10 into this number. So when you multiply these two, it becomes 6022, have a 0 here, into 10 raised to power 23 molecules of water, right? This is molecules of water. So when you put decimal point, after 3 digits from the back, 1, 2, 3, it becomes 60 point, yeah, that's it. And now the final thing is, you want to write this answer in the scientific notation form. So when you write the answer in the scientific notation form, you'll have to place this decimal point right after the first digit from the left side. It is 6.022, 0 into 10 raised power 23 molecules of, okay, H2O, that's it. So you will finally write therefore the number of molecules of water or H2O in 10 moles of water is 6.0220 into 10 raised power. It becomes 24. This, sorry, 23. When you shift the decimal point to the left by 1 digit, you add 1 here, the exponent becomes 24. That's it. So this is one example for you. And now next, we're going to take up another example, right? And that is find the number of molecules of hydrogen in 200 grams. Let's see now if you can try out. Let's call the question number 3. Find the number of molecules of hydrogen. Molecules of, that is dihydrogen, dihydrogen in 200 grams of hydrogen. 200 grams of, okay, HCl. Let's see now. Here, you're given 200 grams of dihydrogen. That is 200 grams of dihydrogen. You are asked to find the number of molecules again. You got to think of this Avogadro number, right? And before that, we should know the molar mass of dihydrogen. In fact, the molar mass of dihydrogen is 2 grams, right? Okay, that's it. Now, as far as dihydrogen is concerned, 1 mole, that is 1 mole of dihydrogen contains, you know that 1 mole of dihydrogen contains how many? 1 mole of dihydrogen contains how many? It is again the same number, 6.022 into 10 raised power 23 molecules of dihydrogen. Now this 200 grams of dihydrogen should be converted into moles. We know that the molar mass of dihydrogen, see, that is dihydrogen molar mass of dihydrogen is 2 grams, right? 2 grams. So when you have 200 grams, so that is 2 grams is 1 mole. Now when you have 200 grams, this is equal to how many moles? So you take it as X, it's actually very simple, it becomes 100. You just cross multiply your X is equal to 200 grams into 1 mole and divided by 2 grams here. So it is 100 moles. You're going to get 100 moles. Now this is one way of doing it. So now your 100 moles of H2 contains, let's take this X. And then now when you simplify this expression, you will get the value of X, which will give you the number of molecules of dihydrogen in 200 grams of hydrogen. So X is equal to, you write this as 100 moles into 6.022 into 10 raised power 23 moles of dihydrogen divided by 1 mole here. And then mole and mole get cancelled. Finally, just multiply these two. It's going to become 6022. Add 2 zeros here. 10 raised power 23. The decimal point comes here. And then finally, when you shift the decimal point to the left by 2 digits, it's now 6.02200 into 10 raised power. You're shifting it to the left by 2 digits. So this exponent here increases by 2. It becomes 10 to the power 25. It is now 25. Yeah, this is not moles, contains, this is molecules. This is molecules. I'm sorry, it is molecules. Molecules are dihydrogen, I'm sorry. Molecules. So this is 6.02 times by 25 molecules of dihydrogen. That's it. So I hope you understood this. Now the next part is, we will now move on to finding the number of molecules of water in, find the number of molecules of water in C. I'm going to make this 36 grams of water. Molecules of water, 36 grams of water. This is what I put now. So let's see. This is your problem number 4. Number of molecules of water in 36 grams of water. Now, again, let's see how you can work it out. This 36 grams of water is nothing but 2 moles, isn't it? 2 moles. So, this is 36 grams of water is equal to how many moles? 2 moles of water. 2 moles. Now, this is equal to 2 moles. You know how you get it? Because, see, as far as water is concerned, its molar mass. Here, molar mass of water is 18 grams, right? 18 grams. So, when 18 grams of water is 1 mole, then 36 grams of water is how many moles? X cross multiply X, okay, same thing. So 36 grams into 1 mole here, the whole thing divided by, 1 gram here, so 18 grams here. So it is nothing but 2 moles, right? You got it here. So this is 2 moles. So 36 grams of water is nothing but 2 moles of water. Now, finding out the number of molecules of water in 36 grams is the same as finding the number of molecules of water in 2 moles. Now we know that 1 mole of H2O contains how many? 6.022 into 10 raised power 23 molecules of water, right? Now since 1 mole of water contains 6.023 molecules of water, you can easily find how many molecules of water in 2 moles of water, right? So in 2 moles of H2O, this will contain how many? You take it as X. Again, same thing, just cross multiply, and this is 2 moles of water multiplied by 6.022 into 10 raised power 23. This is molecules, molecules. Then divided by 1 mole comes down here. And then these 2 mole and mole get cancelled, so finally 2 times this number. So it is 2 2s are 4, 2 2s are 4 here, 0, 2 6 12, alright, into 10 raised power 23 molecules, molecules of water, right? L is the molecules of water. And now the decimal point 3 digits from the back side, so it comes down here. And finally, when you write this in the scientific notation form, it becomes 1.2044 into 10 raised power 23 molecules of water. Alright, this is how you work it out. And now the last example here is with regard to finding the number of atoms. So let's see how you can work it out. The next one is problem number 4. So here the question is, problem number 5 is this. So finding the number of molecules of number of atoms of hydrogen. Okay, so finding the number. It's finding the number of you're going to find, right? Find the number of atoms. Yeah, it is find the number of atoms of, say, hydrogen and oxygen in here. You're going to take 5 moles of water, right? 5 moles of water. So let's see how you can work it out. This time you will have to find the number of atoms. Now atoms of hydrogen and then atoms of oxygen, 5 moles of water. So this is H2, right? Water. Now this is, if you consider this as 1 molecule of water, in 1 molecule of water you have 1 atom of oxygen, right? 1 atom of oxygen, and then this is 1 atom of oxygen, and then here in 1 molecule of water you're going to have 2 atoms of hydrogen. 2 atoms of hydrogen. So let's see how we can do this. Now, see, in 1 mole of water, you have 6.02 to 10 to the power 23. Let's see. So, in 1 mole of water, 1 mole of water contains how many atoms of oxygen? Now, in terms of molecules, it is 1 mole contains 6.02 to the 10 to the power 23 of atoms. That is 6.02 to 10 to the 23 atoms of oxygen in 1 mole. So let's see, 1 mole of water contains 6.02 to the 10 raised power 23 atoms of oxygen, right? Oxygen. So when you have 5 moles in 5 moles of water, so 5 moles of water contains how many atoms of oxygen? We're going to put X here. So here, what will happen is, since this again it's a case of direct proportion, you just cross multiply. X is equal to, you have 5 moles of water here multiplied by 6.022 into 10 raised to the power 23 atoms of oxygen divided by 1 mole here, right? 1 mole of water. Mole and mole get cancelled. So finally, the number of atoms of oxygen in 5 moles will be the product of these two. The product of these two is 5 to the 10 there. 1 remains, 5 to the 10, 11. 1 remains 5 zeros, so it's 1. It's again 1 here. Then 5, 6, 30. And you're going to put the decimal point. This is atoms of oxygen, right? Now the decimal point, after 3 digits from the back, 30.110. You write this in the scientific notation form, 3.0110 into 10 raised to the power. You have shifted this into the left by 1 digit, so this becomes 24 atoms of oxygen. Atoms of oxygen. So this is the number of atoms of oxygen you find in 5 moles of water. Now the interesting thing is with regard to the number of atoms of hydrogen. Atoms of hydrogen in 5 moles of water. So the last part here, I'll just show you. Okay, that is